This video covers similar polygons, where we will understand similarity in polygons and use proportions to solve problems involving similar polygons. So first of all, what are similar polygons? Similar polygons have the same shape, but they're not necessarily the same size. So we say two polygons are similar if and only if their corresponding angles are congruent and their corresponding side lengths are proportional. What that means in this trapezoid ABCD is similar to trapezoid EFGH. The special notation for similarity I'll call trapezoid ABCD like this, and then it's a squiggle. So like the squiggle that goes on top of a congruent sign, it's just the squiggle alone, is similar to EFGH. That means that the corresponding angles are congruent. So that means that angle A, so that's the first angle right here, is congruent to angle E, this first angle right here in that trapezoid. And then the second angle B is congruent to the second angle right here, F. Angle C is congruent to angle G, and angle D is congruent to angle H. So in both of these trapezoids, all their corresponding angles are congruent. And their corresponding sides are proportional. So that means like the ratio between, I'll go up here, the ratio between AB and EF, this first segment right here, is proportional to the second side, BC to FG. So these two similar trapezoids, all of the corresponding angles are congruent, but all of their sides are proportional to each other. So AB to EF is equal to BC to FG, and then CD to GH is equal to DA. Can you see that? DA to HE. So I just talked about the proportions of the corresponding sides and how similar polygons have their corresponding sides are proportional. The ratio of the lengths of those corresponding sides are called the scale factor. A scale factor tells you how much bigger or how much smaller the polygons are to each other. So in this diagram, triangle ABC is similar to triangle DEF. That means that all the corresponding angles are congruent. So angle A is congruent to angle D, and angle B is congruent to angle E, and angle C is congruent to angle F. But it also means that the sides are proportional to each other. So that means that AB to DE is equal to BC to EF, which is also equal to CA to FD. So that's just a side note. But if we're trying to find the scale factors from the scale factor from triangle ABC to triangle DEF, it would be consistent in the ratio of AB to DE, these two sides that I know the lengths of, which would be 6 to 18, which is 1 to 3. So the scale factor from triangle ABC to triangle DEF is 1/3. Now if I asked you for the scale factor of triangle DEF to ABC, triangle ABC, that would be a little different. You would take the side DE and divide it by the side AB, 18 over 6, which would be 3. So the scale factor from triangle DEF to triangle ABC is 3. All that means, maybe in this case, in the first case, triangle ABC to triangle DEF, is I'm going to take 1 unit for side AB and multiply it by 3 to get the other side of the corresponding side up in the other triangle. Okay, so we can use scale factors and proportions to solve problems involving similar figures. So say I have this quadrilateral and it's similar to this quadrilateral. I can use the corresponding side lengths to write a proportion. So if I know that AB over EF, AB over EF is equal to CD over GH, CD over GH. So I'm taking the first side, setting that ratio equal to the last side. Then I plug in what I know. I know that AB is 45. I know that EF is 2x plus 4. I know that CD is 40. And I know that GH is 16. I have this proportion I can solve for x. So I just use the cross products and have 40 times 2x plus 4 equals 45 times 16. I made sure I put the parentheses in there, so I'm going to distribute the 40 to everything. So it becomes 80x plus 160 equals 45 times 16, which is 720. So I'll subtract 160 from 720, and I get 560, and then divide 560 by 80, and I get x equals 7. So that's an example of using similar figures to find missing measures. So we're going to use the scale factors to solve problems by using this concept of perimeters of similar polygons. It is a theorem. It's the perimeters of similar polygons theorem. And it says if two polygons are similar, then their perimeters are proportional to the scale factor between them. So what that means is if WXYZ is similar to A, B, C, D, then the perimeter, so the perimeter of a polygon is just you're adding all of the sides. So the perimeter of WXYZ would be WX plus XY plus YZ plus WZ. And the perimeter of ABCD would be AB plus BC plus CD plus DA. So the perimeter of those two polygons is equal to or is proportional to the scale factor between them. So the scale factor would be just the ratio between any two sides. It could be WX over AB, or it could be XY over BC, or it could be YZ over CD, or it could be ZW over DA. I'm going to do an example problem involving this idea. Okay, so here I'm going to use a scale factor to find perimeter. So I have polygon ABCDE. It's similar to polygon PQRST. So I only know a couple of things about each polygon. I know that this side is 8, AB is 8. I know that side ED is 6. And I know that AB is congruent to BC and AE is congruent to CD. That also means that if AB is congruent to BC, that PQ has to be congruent to QR. And if CD is congruent to AE, that means that RS has to be congruent to PT because the two polygons are similar. So the first thing I want to do is find the scale factor. So the scale factor from ABCDE to PQRST would be, this is, you know what, I forgot to put this in here. This is 4. So RS, so CD to RS is going to be the scale factor, which would be 4 over 3. So that's the scale factor from ABCDE to PQRST. So since these two are congruent and these two are congruent, then I can find the perimeter of ABCDE. So the perimeter of ABCDE is 8 plus 8, there's two sides of 8, plus 4 plus 4, there's two sides with 4, and then the plus 6. So that equals 30. So the perimeter of ABCDE is 30. So now we can use the perimeter of ABCDE and the scale factor between the two polygons to write a proportion so that we can find the perimeter of this other polygon. So here's a scale factor, 4/3. That's going to be equal to the perimeter of ABCDE divided by the perimeter of the other polygon, which is PQRST. So we can write it as 4/3 equals 30 over x. And then just use cross products. So it would be 3 times 30, which is 90, equals 4x. So x, if I divide by 4, then x would equal 22.5. Okay, that's it for the video. Let me know if you have any questions.